Hey ladies and gentlemen, and welcome to Unit 9 Notes 3-3, Simplifying Rational Expressions with Monomials and Factors. Okay, so today we're just going to focus on that part, and tomorrow we're going to add in that factoring piece. Okay, so to start off with, when we're talking about simplifying rational expressions, to simplify a rational expression, you must eliminate any common factors in the numerator or the denominator. So you have to get rid of those. But remember what we talked about yesterday, that when we state the excluded value, you need to make sure that you also include the factors that are going to be eliminated. You need to do both. So let's take a look. So let's go ahead, and first thing I want to do for number 1 is I want to calculate out the excluded value. So I'm going to set the denominator equal to 0. Well, that's really easy. So my excluded value is that x cannot be 0. Okay, so that's step number 1. Now we have to go through and we have to simplify it. So I'm just going to write it out like this. So I have a 2 on the top, and then I have 2 x's. Then on the bottom, I have an x. So I'm going to cancel out those overlaps. So then I'm just left with 2x. So this is my simplified form. Simplified, there we go. And this is my excluded value. You need to have both for each question. You need to have a simplified value, and you need to have, a simplified expression, and you need to have an excluded value. Let's take a look at number 2. So for number 2, we want to find the excluded value. So I have a squared is equal to 0. Now this is a little bit tricky. So here's what I'm going to tell you. If you have a thing that's just a letter, there's a 1 out front, even if there's an exponent, no matter what that exponent is, in order for this to equal to 0, a has to be equal to 0. So my excluded value for number 2 is that a cannot be 0. So that's step number 1. Step number 2, we want to simplify this out. So we have 4, and then I have 3 a's, and then I have 2 a's on the bottom. So again, I want to cancel out what's overlapping. So I'm going to cancel out those a's and those a's. And then I'm just left with 4a as my simplified version. So I actually end up needing both of those answers for each of these. Let's take a look at number 3. So let's find the excluded value. So we have a to the 4th is equal to 0. Now we want that positive coefficient of 1, and then we have an exponent up there. It doesn't matter what the exponent is. In order for that to be equal to 0, a has to be equal to 0. So our excluded value is that a cannot be equal to 0. So let's go ahead and write out what we have. So I have 2 a's on top and 4 a's on the bottom. So I'm going to cancel 2 of those out. So on the top, I just have left 6. Now notice that my leftover a's are actually on the bottom. So I'm going to write them on the bottom. But I don't want to leave it as AA. I want to write it as 6 over a squared. And that's my final answer. So you need, again, both of these for your answer. I'm going to go ahead and have you guys try number 4 on your own. So make sure you write out all of your Q's. Let's get a little head start on it. So you have a 3 on top, and then you have 6 Q's on top. And then you're going to have 9 Q's on the bottom. Okay, just to help you get canceling out. And make sure you also find your excluded value. So q to the 9th is equal to 0. Figure out what value is going to make that true. Think of it this way. For this one, in order for a times a times a times a to be equal to 0, we're going to have to multiply 0 by some point. So 0 times 0 times 0 times 0 is going to be equal to a. So that's why a to the 4th, in order for that to be equal to 0, a has to be equal to 0. So use that idea for number 4. Now let's take a look at number 5. I think it looks a little bit scarier than it is. So the first thing we're going to do is calculate out that excluded value. So I'm going to take 7x squared, y to the 3rd, and set that equal to 0. So what I'm going to kind of do is I'm going to kind of use a fake version of the zero product property. So I'm going to take each factor and set it equal to 0 to see what my excluded values are going to be. Well, 7 is never going to equal to 0, so I don't have to worry about that one. So when is x squared equal to 0? Well, only when x is equal to 0. And when is y cubed equal to 0? Well, only when y is equal to 0. So for this one, my excluded values are that x cannot be 0 and y cannot be 0. Now remember, for those excluded values, we strike out the 0 because we want to figure out when it is equal to 0 and say, hey, we're not going to count those anymore because they're getting in the way. So let's go ahead and simplify this out. First thing I want to do is reduce the fraction that I have. So currently I have 7 over 14. Well, 7 divided by 14 is 2. So I'm going to write that as 2 over 1 because for right now I need to have a top and the bottom. And on the top I have 2 x's and 5 y's. On the bottom I have 2 x's and I have 3 y's. Okay, so then let's cancel out what we know. Those x's cancel, and then we can cancel out 3 y's. So then we have 2, and then I have y times y. Well, 2y times y is going to give me 2y squared. So that right there is my final answer. So here's my simplified version, and here is my excluded value. Why don't you guys go ahead and try number 6 on your own? Just as a little hint, you want to reduce the fraction 5/10 to 1/2. Okay, so that's just a little hint as you go through and simplifying it. Okay, let's take a look at number 7. So for number 7, first we have to find our excluded value. So I'm going to take 9x to the 6th, and I'm going to set it equal to 0. Well, let's use that mock zero product property and set each part equal to 0. Well, 9's never going to be equal to 0, so we can get rid of that. X to the 6th is only going to be 0 when x is equal to 0. So our excluded value is that x cannot be equal to 0. Now we want to go through and do some simplifying. So the first thing I want to do is multiply the -3 and the 4. And that's going to give me -12. And then I have 2 x's, and then I'm going to have 5 x's after that. On the bottom, I'm going to have 9, and then I'm going to have 6 x's. So let's go ahead and cancel some things out. Well, first of all, we can reduce the fraction 9 over 6. Those are both divisible by 3, so I'm going to write that as a -4 thirds. Now let's cancel out some x's here. That cancels, that cancels, that cancels, that cancels, that cancels. So all we have left on top is that 1x. So -4 thirds x is our simplified version. Let's do the same thing with number 8. Let's set the bottom equal to 0. So we have 4y to the 8th is equal to 0. So let's use that zero product property. So we have 4 is equal to 0, y to the 8th is equal to 0. Well, that's never going to happen. Y to the 8th can only be 0 when y is equal to 0. So our excluded value is that y cannot be equal to 0. So now we're going to go through and write out a simplified radical. So first thing I want to do is take -4 times negative simplified radical, simplified expression. That was last unit. -4 times -8 is, or -2 is +8. Then we have 3 y's from the first one, and we have 6 y's from the second one. Then we're going to divide that, and we have 4, and then we're going to have 8 y's on the bottom. So it's 1, 2, 3, 4, 5, 6, 7, 8. So the first thing I want to do is reduce that fraction. So 8 divided by 4 is going to give me 2 over 1. Now let's cancel out some y's. That cancels that, that, and that. So all we have left is 1y on top. So 2y over 1 is the same as 2y. So that right there is your final answer. So again, you need both of these answers for each question. Okay, let's take a look at number 9. So for number 9, we have things in factored form, kind of like we had on Monday. So what I'm going to do first is I'm going to set each denominator equal to 0. So x plus 3, x minus 1 is equal to 0. Well, that's going to require me to use the zero product property. So this is going to get x is equal to -3, and this is going to get that x is equal to 1. So these two are my excluded values. So when I write them as excluded values, I want to cross them off so we don't include those numbers. Now I see that I have x plus 3 on the top. Even though there's no parentheses there, you can pretend there is. Because it's just x plus 3 on the top. There's nothing else up there. It's just x plus 3. I can go ahead and I can cancel that out with x plus 3 on the bottom. Now notice the x minus 1 is on the bottom, so that needs to stay on the bottom. Now when we canceled x plus 3's out, the x plus 3 over x plus 3, that's going to leave us with 1. Okay, so this right here is our simplified radical. Let's do the same thing with number 10. So to start off with, I'm going to take x minus 4 and x plus 2 and set that equal to 0. So then I'm going to set each factor equal to 0. So here I get that x is equal to 4, and I get that x is equal to negative 2. So my excluded values are that x cannot be 4 or negative 2. But I'm not just calculating out the excluded values. I also want to simplify. That's the new thing we're adding today. So I notice that x minus 4 is on the bottom, and there's just the x minus 4 on top. So that means that I can go ahead and I can cancel those out. So notice again that x plus 2 is on the bottom, so I want to keep it on the bottom. And then everything on the top cancels. When everything on the top cancels, we're going to write a 1. Okay, so biggest thing you need to know is that you take the excluded values before you simplify. So take those excluded values before you simplify. Let's take a look at number 11. So for number 11, again, we want to set that denominator equal to 0. So x plus 2, x minus 4 is equal to 0. So x plus 2 is equal to 0. X minus 4 is equal to 0. So here, subtract 2 from both sides, you get x is equal to negative 2. Here you get that x is equal to 4. So our excluded value is that x cannot be negative 2 or 4. So that's one of our answers. Now we need to get our simplified version. So notice how everything up top is being multiplied and everything on the bottom is being multiplied. Okay, so the biggest thing you need to know about that is if everything's being multiplied, that's why we can cancel things out. Okay, see how each of those factors are being multiplied. If we just had a bunch of factors being added, we couldn't do this, but because they're all being multiplied, we can. So I can take this x plus 2 and cancel it out with this x plus 2. And then left on top, I have that x minus 3. And then on the bottom, I have that x minus 4. So this right here is my fully simplified rational expression. I'm going to go ahead and have you guys try number 12 on your own. It's very similar to number 11. Let's take a look at number 13. So for number 13, to get that excluded value, you want to take and multiply or set this denominator equal to 0 with all those factors being multiplied. So that means I'm going to take each factor individually and set it equal to 0. So then I get that x is equal to negative 2, negative 3, and negative 4. And for my excluded values, we don't want x to be those values because that's what's going to give us a denominator of 0. Now let's go and cancel some things out. First of all, I see x plus 3 and x plus 3. You might look and see this x minus 2 here and this x plus 2 here and think, hey, I can cancel those out. But you can't. You have to have the exact same factor. So even if it's the exact same numbers, the signs also have to be the same. So nothing else can be canceled out. So left on top, we have x minus 2. Left on the bottom, we have x plus 2 and x plus 4. So that right there is your final answer. Okay, that's fully simplified. Last but not least, go ahead and do number 14 on your own. Once you're done, bring up your note sheet and I will give you a copy of the homework. Thanks for listening.